I got to be honest, my friends, I amazed myself at how simple this is. This is the nucleus of an atom. Now, this is Latham's crazy machines. Very, very simple. He's taking a positive core and surrounding it with negative particles, creating what would be a nucleus, and then electrons are going to try to come in, but the electrons that surround the positive core won't let them come in. They'll keep them exactly at a quantum distance, and that is exactly what happens because that is quantum physics. All right, what you're seeing there is a positive core, bam. That's what it is. Now, what are you looking at? You're looking at an electron surrounding a nucleus. This is it right here. Now this is the hydrogen nucleus, and you see it looks like a ton of different particles and it's only supposed to have one proton? No. The nucleus of every single atom has more and more and more and more electrons, and all there is electrons. Now, because of the dark part of the electron, it has a weak force, and then there's the other part of the electron. Usually it's white or red or green. It's that's the explosive part, and that they will not stay together. Those will push away from each other, just like he's got them stuck outside the positives, and that creates a negative shell pushing out these. Now, if this is locked in like a crystalline structure, there will be a pocket here, and that pocket will maintain that electron in that pocket. Now, as they get more and more complicated, they get more and more pockets. I'm going to show you that right now. This is, in toys, I can show you exactly what's happening in the nucleus. And they admit now that the nucleus, they have no idea about it anymore. All right, so now you know that he's got a two-dimensional plate here, but here's what he's going to do. He's got a three-dimensional magnetic field, and now he's going to be able to show us how that works. Watch, you see these up here? Now he's coming in with the three-dimensional magnetic particle above. You see what it's doing? It's influencing the others that are around it. So this is what they call the Coulombic forces. Wherever this is, it's going to affect the ones that are out here. Now he's just added something in there and it broke up the way it works. But see how they're cut? Some will pop way out here, way over here. They snap together. That's bonding, literally bonding. It's really incredible how you see this. Now, obviously it's a toy. It's not exactly what's happening in real life, but it's you see what he's doing? Now what he just did, when he shook it, he was heating it. Okay, we're going to be coming back to this in great detail, but these are the different capacitances of the different layers of the atmosphere, and that creates these 7 different Schumann frequencies, and I believe they relate to the 7 different periods of the periodic chart. And it just means that you keep adding more and more and more and more electrons until it's saturated, and then it jumps back to another layer around the core. That's all it is. And I'll get into it deeper. It's complicated, but this guy really makes a lot of sense. And it goes to ancient wisdom. It's very, very interesting. All right, I just showed how the quantum effect works with the nucleus. Now, you see these Schumann resonance, they're different frequencies. And there's 7 different layers here, the periods in the periodic chart. And that relates to capacitance. The different layers of our atmosphere get thicker and thicker and thicker as you go down. That means capacitance increases. That means the Schumann resonance frequency stability is going to change. Flip, 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 and it goes 7 times. So in other words, here it's like way down at this end, it adds a little few more electrons, more, and then it's full, and it comes back to the next range. And I'll show you that now in the salt, because salt is nothing more than polar molecules. Salt is on both sides, NaCl. Okay, so when it vibrates, it's nothing more than particles vibrating. And I'm going to show how the density of the space changes the way they form their molecules. All right, we all know that as you go up in the atmosphere, it gets thinner and thinner. So down here it's thick, it's got a lot of capacitance, that's the symbol for capacity. And up here it gets less and less capacitance. You got your hydrogen, helium, and things like that. Your very light molecules are up in here. So what ends up having is it's a different discharge from the capacitance. And you're going to see that in salt. And this is going to be salt. Now let me turn this down a little bit. Now this is Bruspup. Alright, this is Bruspup and amazing resonance experiment. Now, what they're going to do is take this plate, which is nothing more than a steel plate, and they're going to vibrate it with hertz. And that means they're putting a positive and a negative on it, like this. Now, what does that do? Well, it causes the salt to react positive and negative like this. Now, at a certain frequency, they become stable. And you'll see it goes up just exactly the way molecules form. From smallest with only two like this. So you have this in the center, and then you have two, and that's as much as you can get. Now it'll show with four of them, but only two of them can be occupied. Then as you go up into the next, they call this the lowest S orbital. Then you go into the next orbital and you start into the rule of 8, and it's obvious. And the reason that they're changing is because that same size, which means they're pushing more and more molecules because of the vibrations, which will happen as you get closer and closer to the Earth. They're tighter and they're more and more vibrating. That's why you end up with these different regions that start to become stable. All right, so here goes. They're going to start vibrating the plate. All right, now all of this salt, NaCl, so it's a polar molecule, and it's just laying all over. Vibrating the plate is with a tone generator is nothing more than going positive minus, and the pitch is going bzzz, and as they go up, you hear it? Now watch, they'll start to shake. Boom, it locks in at 345 hertz, and that's the center where the nucleus is. And then you could have an electron here, or you could have one here, or you could have two, one here or here, one here or here, that type of thing. They're going to be opposing each other, or they'll just be one, which will be a hydrogen. Now, then it goes up from this. This is your lowest S orbital. Now all of a sudden it's going to start taking on these regions of 8. And the same thing. Here now you have your central core, and then you got 1, 2, 3, 4, 5, 6, 7, 8. Those are the regions of the electrons now. All right, and then that's at a certain frequency. And then as you go to the next frequency, it just keeps getting more and more complex, but you still have these rules of 8. And the reason they're getting more and more complex, and the frequencies are getting higher and higher, is because you have this the more activity in the same volume, just like you would on the Earth. When you go up from the Earth, you've got more activity in, where it gets less and less dense, that type of thing. Maybe the other way around, but you understand what I'm saying. You're changing the capacitance level of the particles in that layer of the atmosphere. They're going to be able to absorb more and more as they get lower and lower towards the Earth, and then you're eventually going to have all these discharges of lightning and everything else. And these will just keep getting more and more complex, but still have this same pattern of 8 as you get higher and higher in frequency. Okay, my friends, we're going to go into it right now, electron flood theory, and now how, after 50 years, it finally makes sense. I studied this stuff pretty deep about how all of the different orbitals worked, and salts and acids and metals and all of that. It's about as deep as you can go with it. And I ended up not really being able to account for the structure of the nucleus. And nobody could, even to today. But now I can, because it's electron flood theory. And I'm going to show this. I think I have evidence to literally prove what I'm saying. And that there is nothing but electrons. And if they add together in certain ways, they are certain materials. And some of them are salts and acids and metals and fluids and liquids and all kinds of different arrangements of the particles that are just zillions of particles all collected together and bonded in certain ways so that they become stable in the environment that they're in. And that's what creates these different periods here. All right? And so your hydrogen and your helium, that fills the first level right here. That would be helium. That would have an electron and an electron. But in here, you have, instead of having two protons, you have like 3,600 or 4,000 particles inside there, and they're all electrons. It's the same mass, but only electrons. So say a proton is 1,837, I believe is what I calculated out to be, electrons. So if there was one proton in here, it'd be 1,837, and there'd be one particle out here, which is an electron. That would be your very base hydrogen. That's your basic, tiniest particle. Right? Because that's all electrons. Now, these electrons, the positives, do not fight each other. The positive black parts. They don't fight each other. They'll just go right up together. It's no big deal. They're the weak part. But the red ones, which normally they would be white in, if this was light, they don't want them to be near each other. So they're going to have a distance between them. That sets up like a rhine around the positive core. And still electrons want to come in, but they say, no, you can't come in here. We've got so many now already on this layer of negativeness that you can't get here. So stay off and stay right out there. You can float over here, and I can do this, but you can't come any closer. And if somebody comes in and pushes you, you're going to vibrate, and we're going to get hot, and we're going to start creating energy. And that's what happens. You can see it when these things get crushed through a venturi. They explode, as we are going to see. Okay, we are going to get extremely geeky. Now, we all know that the Earth has an atmosphere that surrounds it, and that we spin through that atmosphere. And what they don't understand, though, is what's outside of our atmosphere, which is the gases that are held to our Earth, is all of the particles of light and all of the gases and things that are in the vacuum of space. They call it a vacuum. It's not a vacuum. It's saturated with light. So our field of particles is spinning through those particles, creating a magnetic disturbance, which is our Schumann frequencies. All right, Schumann resonance frequencies. And what happens is the Earth vibrates. And it vibrates at 7 different frequencies. And they're from shorter to longer, but they're still extremely low. They're the lowest frequencies there are. And a little scary to be screwing around with this stuff, because they were looking at them. Are they stable, or do they stay the same? And yes, they do. They're this is what they are. They're well, let me just play this and see what it has to say. All right, lightning radiates these fields, and they excite the Schumann resonance, because they're nothing more than pushing more particles in. That's what excitation is. That's what heat is. That's what electrical flow is, pushing more particles in. And this is our atmosphere. All right, so here's the Earth. Here is our ionosphere, stratosphere out here. Now what you have to remember, it's only like 80, 90 degrees down here. Out here it's 1,000 degrees, more than that. And the reason is, we're scrubbing through particles that are all out here, that are all out in the stratosphere, all in there, and they're creating a vibration. And it seems to have just like a tuning fork. If you actually you take a tuning fork and go through the air, you can make it harmonize. And it's something like that that's causing this Schumann resonance. And it's set up at a certain frequency, and there's like 7 of them as it comes down towards the Earth. And that goes along with capacitance. I now understand that electron flood theory means there is nothing but electrons. Light is nothing but little boxes of electrons. There is no protons. Protons are nothing more than a ton of electrons added together. And you take a bunch of them, and you can go up to lead or gold or as high as you want. And you can go down to hydrogen as low as you can get. And in between, you've got like the 7 different places on your periodic chart. I have one around here somewhere. But anyway, oh, here it is. All right, so you got 1 through 7. And they just keep adding more and more and more and more electrons until you get up to a stable chunk, and then it starts over again back here. And it's stable, and then it gets back here, and more, and then it gets back here again. And that's these 7 different vibrations. Now, I haven't accounted for this completely. I mean, this is all pretty new stuff. But the electron density in the atmosphere, it just thins out as you get higher up. That's just everybody understands that. There's no dispute about that. So what does that mean in electrical terms? It means capacitance. See, this just means capacitance. It means there's more capacitance as you go closer to the Earth. The Earth can hold more electrons. Right? And that's all a capacitor is it's like a bucket holding electrons. And out here you can't hardly hold any. Now, they're doing things with this 5G that I think somebody should do a little more looking, because 5G is a frequency that it's exact a certain frequency that's just supposed to stop completely out here. Absolutely stop. And why would it stop? Because of water molecules. Okay, because of our atmosphere. The atmosphere blocks it. That specific distance between those little particles says you can't get through here, and they just blip, stop. Now we're putting them right on the surface of the Earth and forcing them to penetrate right in where we're living. No, it's not supposed to be that way. It's just not supposed to be that way. Now, whether or not they can show that it doesn't cause any damage, I have to find that hard to believe, but I don't think they've tested it for that, though. Really, not the way they should. But I have no control over that. But anyway, the atmosphere is thin up here. It gets thick down here. But in the meantime, you have all your clouds and your air, your moisture molecules, and those are the things that absorb microwaves. And what we're doing is forcing microwaves down here. Not a good idea in my mind. Okay, my friends, here's where it gets interesting. This is the surface of the Earth down here. All right, we have our troposphere, and we have lightning storms, and our magnetic interaction happens down here where the weather events occur. All right, now above that you have electron interactions. You have these sprites and electron jets and gamma rays and halos and ionosphere and these elves and so forth. So in other words, up here you have interactions amongst themselves. Down here you have interactions which lead to the surface of the Earth, which means the density of electrons here wants to flow into the Earth. And the reason it does is because the Earth is a spinning ball of particles, which are electrons, around the Earth's surface. As those electrons scrub through the ionosphere out here, which is nothing more than a bunch of more particles out here, it's scrubbing through that. That creating this magnetic interference. It's nothing more than a generator effect. It's exactly what it is. Now, the deeper you go through the atmosphere, the thicker the atmosphere gets. And that is also affected by things that are happening on the Earth's surface as well. You have your spinning atmosphere, and that's why you see cloud formations and hurricanes and tornadoes and all that stuff. That's up in this region right above here, actually. But up in here is where we're getting all of our resonance formations. And that's a little tricky. That one there I'm going to take a little closer look at. Because down here, I can understand it. We know what's going on down here. That's the weather patterns. But when you get up in here, that's where these new events that they're looking at, sprites and so forth, are taking place. So there's a lot to electron flood theory, but it is all electrons. That's all there is. And we are surrounded by them in our solar system everywhere. They are literally the dark matter and the dark energy. And the only time we see them is when they scrub around our surface, or they come in and hit you in the face and give you a sunburn. Okay, my friends, as promised, we will eventually get into Anton talking about what actually is lightning. And I can tell you what it is. It's electrons, and it's raw electrons. Zzz. It's not like matter falling through space. This is 100% electrons. Same as the 100% electrons that collect on you as static, and then it discharges to ground. And just same as exactly like electricity when you discharge it to ground, because ground wants it. However, when it hits the ground, it has to incorporate itself, because that's all it is electrons. And that's why it burns whatever it burns into in the ground. That's why it's so destructive. It has to burn its way into those molecules. It doesn't just drop like this and land on something. It's got to be these particles and go bzzz, and that doesn't feel good usually. Okay, we're going to be getting into this very deeply, but there is some changes now happening in the 7 subtle vibrations of the Earth. And the reasons that's going to happen is because there's only 2 things that can cause that to happen. Either the Earth has got more energetic particles that are crushing through the same particles that were surrounding it in space, or the space that's surrounding it has more energetic particles, and the more energetic particles in here are scrubbing, and between the 2 of them you're getting more and more frequency, and you're getting more and more excitation, and that is causing, I don't know what, but it's not, they're talking about it for planetary rhythms and human health, and there's a lot of speculation that it may be causing problems with human health. And we are a tuned system. And once we get out of this tune, And these hums that are coming into us, you know, we work with electrical signals. This is very, very deep. You should come down here and read this. I was very, very impressed. And they're measuring the brain waves and the different cycles that are in your brain. And, you know, I didn't go through the whole thing yet, but I am gonna. And it's things that we're not thinking about that are the things that are going to get us. And, you know, the scientists think you can just do anything you want and everything's going to be fine. There are underlying principles that are being violated, and even when they're brought to 100% evidence, they're just ignored. For whatever reason, I don't want to speculate on the reasons, but that's what happens. All right, I'm going to cut it off for today, but we're going to get really deep into all of these things because I have to explain every single molecular interaction and light interaction and heat and cold and friction and how our magnetic field is propagated and why I believe right now we are overcharged. And I don't know if we can discharge into space to bring our interaction back under control. I think we're going to be overheated, and that's what they talk about. You know, they think it's carbon dioxide, greenhouse effect. Well, that's not. It's we're over scrubbing the particles that are in space, creating an excessive generator effect. And I don't know if they can discharge out. I think they're just growing and growing because of the extreme amount of chemical interactions that we're creating, whether it's burning things or whatever. But once you liberate these molecules, I mean these electrons, and then they become free, they take up a lot more space. That's the problem.